folks, welcome back to the fourth video in the 5.3 section. We're going to talk a little bit more about the example we left off with in the last part of the video. And so last time we were here, we were looking at example 9, and we said, okay, we can use what we know about the definite integral, which also is known as the fundamental theorem of calculus part 2. So we can use this definite integral to help us find the area between the curve and the x-axis from a given a to a given b, all right? But there's one thing that I want us to show us, which is what happens when we make sign mistakes, okay? So when I look at this picture, I can tell that there's an area there, and I can tell that that area is negative. So I should know that my answer is going to be a negative number, okay? But here's what happens if maybe you made some sign mistakes. All right? So let's say you went back to your f of b minus f of a, and you plugged in and you got 1/3 times 2 cubed minus 4 times 2 minus 1/3 times negative 2 cubed minus 4 times negative 2, and you weren't very careful and you got 8/3 here minus 8, which was fine, but then you got minus 8/3 and then plus 8. Well, let's see what you get. 8/3 minus 8/3 is 0, minus 8 plus 8 is 0, so you would have gotten an area of 0. And it's okay to have an area of 0, but your diagram should reflect that. So this does not match the picture. And so that's a really good indicator that you went wrong somewhere with your calculations, okay? Because we know our answer should be a negative area. Now, there's one thing I want to sort of set the stage for. We'll use this technique a lot later when we get to chapter 6. But if I look at this particular diagram, okay, let me zoom in on the diagram a little bit. If I move in on this diagram, I can actually see that this half, the half that I shaded in the purple, is equal to the other half. And if I think about the x values, this is an x value of 0, and it goes to an x value of 2. So what I could do is double a certain area. So double the area from t equals 0 to t equals 2. Let's see how this might be beneficial, especially for those of us who nobody likes to, but who tend to make sign mistakes. So I'm going to say 2 times the integral from 0 to 2 of t squared minus 4 dt. So 2, I have 1/3 t cubed minus 4t, but this time my bounds are 2 and 0. So how does that change what we get? Well, 2 times 1/3 times 2 cubed minus 4 times 2 is the first part, minus, look at what happens when I plug in the bottom bound. 1/3 times 0 cubed minus 4 times 0. This last part is a gift because it goes away. And so all we really have to worry about is whatever we get here and then times 2. So 2 times 8/3 minus 8, or 2 times 8/3 minus 24/3, which gives us, sorry about writing backwards here, but that'll give us, that will give us a negative 16/3, which will give us the same thing we got up there, okay? So for those of us who tend to make sign mistakes, or just want to go through the calculations a little faster, if you have a symmetric area, try doubling it. Okay, do half of it and then double what you get. It's not a bad strategy. Okay, let's move on to example 10. So here we have a slightly more complicated looking function. It says evaluate from the area from 1 to 9 of x minus 1 over the square root of x dx. And so here we've got a picture that represents what we're trying to find. I know based off of looking at this diagram that at the end I should have a positive area. Okay, so if I don't get a positive number at the end, something went wrong. And the other thing I can say is, can I use symmetry here? And the answer is no, because this region is not symmetric. So this trick that I used here from the last one where I double the area, I can't use it for this case, all right? But what I can do is figure out how algebra can help me simplify. So let's take this problem down here and let's get started. So the integral from 1 to 9 of x minus 1 over x to the 1/2 dx. And that is going to equal the integral from 1 to 9 of x over x to the 1/2 minus 1 over x to the 1/2 dx, which is going to equal the integral from 1 to 9 of x to the 1/2, because this is 1 minus the 1/2 gives me 1/2, minus x to the negative 1/2 dx. Now this is a form that is a lot easier to find the derivative integral of, because I can just use the power rule for integrals. So the integral of x to the 1/2 will give me x to the 3/2, because I have to add 1 to 1/2, and then I take the reciprocal of that power, minus x to the negative 1/2 plus 1 is 1/2, and the reciprocal of that is 2 over 1. No plus c because I have bounds, but instead 9 at the top, 1 at the bottom. Okay, now let's plug in our numbers. Actually, before we plug in our numbers, let's rewrite this with radicals. So 2/3 the square root of x cubed minus 2 the square root of x. And now I'm going to plug in 9 and 1. This would be a super important part for you to show me on a test, because this I know you know how to plug in. This, if you suddenly jump from this to the answer, I'm pretty sure you used a calculator when you weren't supposed to use a calculator. All right, that to me is very obvious. So take the step to rewrite it out and then plug in your numbers. So first one, 2/3 the square root of 9 cubed minus 2 times the square root of 9, minus 2/3 times the square root of 1 cubed minus 2 square root of 1. Okay, 2/3 square root of 9 cubed is going to be 3 times 3 times 3, because I'm going to take the square root of 9 3 times, minus 2 times 3, because the square root of 9 is 3, minus 2/3 times 1, distribute that minus, plus 2. Okay, 3 and 3 cancel, so I get 9 times 2 is 18, minus 6 minus 2/3 plus 2. So I get 12 plus 2 is 14, minus 2/3, which is 2/3, so 42/3 minus 2/3, which should give me 40/3, which is a positive number, which is good. And that is the area that is between that curve and the x-axis. Okay? All right, so let's take a look at one last example, and that'll finish up this section. And that example is a word problem. Now, I wanted to pick a word problem because I think for some of us, it's like, why are we finding these areas? Like, why is area so important? And we're asking the right question, which is, how does it apply to our life? And so in these questions, if we read through this, James and Kathy are racing on roller skates. They race along a long straight track, and whoever has gone the farthest after 5 seconds wins a prize. If James can skate at a velocity of 5 plus 2t, and Kathy can skate at a velocity of 10 plus cosine pi over 2t, who's going to win the race? So this goes back to that idea that if I have position and I take a derivative, I get velocity, and if I take the derivative again, I get acceleration. But if I have velocity and I take the antiderivative, then I will get position. Okay, and that's what we're going to use here. So let's see how far James goes. James. He goes for 5 seconds, from 0 to 5, of 5 plus 2t dt. Okay, let's take our antiderivative. 5t plus t squared, put in the 5, put in the 0. Okay. Well, 5 times 5 plus 5 squared minus 5 times 0 plus 0 squared gives me 25 plus 25 minus 0, or 50 feet. That's how far James travels in 5 seconds. Okay? So if Kathy goes less than that, she loses. But if she goes more than that, she wins. So let's see. The integral from 0 to 5 of 10 plus cosine of pi over 2t dt. Okay. Now for this particular problem, what I want us to do is we're going to find that antiderivative. So we've got 10t plus the derivative of cosine is sine of the thing that we took. But this is something we'll see later. We'll call it U substitution. But basically, it's like backwards chain rule. Okay? So I have to take care of this pi over 2, so it's 2 over pi. Don't worry too much about this part for right now. We'll learn that next week, all right? But for right now, I just want you to know that there's some sort of reverse chain rule. We're going to plug in 5. We'll plug in 0. This will give me 10 times 5 plus 2 over pi sine of 5 pi over 2 minus 10 times 0 plus 2 over pi sine 0. All right, looks like they give us a nice present here. This last term all goes to 0. And so I have 5 times 10 is 50 plus 2 over pi sine of 5 pi over 2. All right, sine of 5 pi over 2 is 1. So really, I have 50 plus a bit more. Like 2 over pi is a bit more. So we know that Kathy travels a little bit more than 50 feet. So Kathy wins the race. Okay? So this is a really good example, again, of why we need to have this idea of antiderivatives and what the fundamental theorem of calculus part 2 helps us find. All right? That's it for 5.3. If you have any questions, shoot me a message. I'm happy to help you out, and I'll talk to you soon.